Welcome to Spring LIB.
All right, so this reaction, we have the following aldehyde in excess, and then we have another aldehyde, which is a 1, 2, 3, 4 carbon chain, 2, 3, 4, like so. And we're performing a two-step reaction. First, basic water, or OH minus, aqueous. And then following that up with heat and more water. Okay, so the first basically step of this reaction is going to be formation of an enolate, which will then attack the other aldehyde. Note that only one of these reagents, namely this one, has a beta hydrogen that can form an enolate, allow this molecule to form an enolate when it's exposed to basic conditions, right? That is, the aldehyde that we have in excess has no enolizable protons. So this can only really serve as the electrophile and not the nucleophile. So upon reacting with base, our enolizable aldehyde will then form an enolate, right? And that enolate will then attack our aldehyde to give us then this alkoxide. And I'm just going to put pH here for the phenyl ring. Okay. Now in this next step, we have heat and H2O. Okay, and that's our sort of, oops, I've done something wrong here. Take a step back. I've added to the wrong side. Sorry. Our new bond is going to be formed, to this carbon here, which I'm marking in red, right? Meaning that we'll have if I mark our aldehyde in blue, right, just to give you an idea of the carbon skeleton, right, it's this red carbon here that will have a bond to this blue carbon attached to the phenyl and our O minus here. Okay, great. And then in the next step is where we get heat and water. Recall that this is basically the sort of disallowed elimination reaction. It's the E1 CB reaction where we actually eliminate OH as OH, right? So effectively what will happen is that the alkoxide will become an OH, right? And then we'll effectively eliminate it and form a double bond between the red and blue carbons. Right, so our final product will look like this. One way you can kind of conceptualize this without having to step through the mechanism that may be helpful in the future. I will color code things again. We've got our phenyl. Like so. We've got our 4 carbon chain aldehyde, like so. And if I color this in red, one way you can think about this is look at the carbon that has the enolizable proton. Imagine cutting this in half and gluing it to that carbon so that you'd get something that looks like this. Sorry, I forgot to put the H here. And that's one sort of shortcut you can do to show the product of these reactions without having to step through the mechanism.